Assalamu alaikum.
Walaikum salam.
Good morning.
Good morning.
Right, so not even a day ago, so we were discussing about vectors. We got some, preliminary idea about vectors, what are the properties of them, and some special types of vectors like surface vectors, and then null vectors and unit vectors. We learned about them. Now let's discuss position vectors. Okay, position vectors. Okay. So obviously, by the term, you can obviously understand that from the position vector, what we get is we will get the position of a vector from a, origin. Okay. All right. So when the position of a vector is specified with reference to origin of a reference frame, what is the reference frame? Remember, what is the reference frame?
Um,
Say, for
uh,
instance, this is a tree and this is a car. Okay. Mhm. Now, they together lay in a reference frame. Okay. Now, when I say that the car is 5 meters ahead, I cannot say like where is it? If I say car is 5 meters ahead of the tree, I can exactly guess where the car is. Okay. So the car is ahead of 5 meter. Car is 5 meters ahead of the tree. That means tree. You would call the tree to be the reference object. This would be a reference object or reference point, you could say as well, reference object. Or if you consider a particular point, then you might consider reference point. And the whole frame it creates, you could call it a reference frame. Okay, understand now? Reference frame.
yes.
Okay, good. So now consider x and y are two mutually perpendicular axes, as we already know. Okay. Now, obviously, where they intersect, that will be our origin. Okay. P is any point. P is any point. Here, OP vector indicates the position of point P with respect to point O. So, if you just join these 2 points and show the direction from O to P, not P to O, okay? That will be our position vector of point P. So, you could say OP vector equals to R vector equals to position of point P, point P with respect to O. Okay. So that means OP vector will be our position vector. Okay. Sometimes position vector is also called the radius vector and is denoted by R vector. Okay. So both the things are the same. Okay. But let's see if they say there is a difference. Okay. The distance of a point from the origin is called the radius vector. Okay. It is denoted by R vector. So actually the same. All right. Okay. Now, what is the use of this position vector? We are going to discover it while we understand our displacement vectors. Okay, and I mean not. Okay, let me show it to you. Then you will understand. Okay, all right. Are you clear with these two things like position vector and radius vector?
Yes.
Okay, good. Now, displacement vector. So obviously, you understand distance traveled by a point along a linear or straight path is called the displacement vector. Like just we have previously read what is displacement. It is a distance traveled by a point along a particular direction, right? It has to be a straight linear direction. Like say, for instance, if I say this to be a distance, then what will be the displacement between these 2 points?
Um, much, it'll just be a straight, no, be curvy.
It won't be curvy, okay? Displacement is always
Dimension.
a straight line, okay? A straight line between the first point and the last point, okay? A straight line between the initial point and the terminal point is called a displacement, okay? So the yellow line here is displacement and red is the distance, okay? Anyway, so the distance traveled by a point along a see linear or straight path. Already I said linear or straight path is called a displacement vector. Previously we learned about only displacement. Now we will like figure it out as a vector. So whenever we will see like say for instance say 5 meter, okay, 5 meter. So this is the starting point, and along this straight point, so this is the A point and this is the B point, not this one, okay. And we are calling this 5 meter distance or this direction to be from A to B. Okay, it's going in this direction, say for instance. Say we are calling it say P vector. Okay. So here P vector will be our displacement vector. Okay. And what is the magnitude of P vector? The magnitude of P vector is equals to AB equals to 5 meters. Understand?
Yes.
Okay. These are pretty much easy things, right? So not that difficult.
Yes.
Now, before seeing this thing, let me check if it's okay. Let me show you one thing. Okay, thing is, when we studied about position vectors, you might as well have thought that what is the use of that. So, use of that is, say, for instance, again, let us consider x-axis and y-axis. Say, this is a particular point in this reference frame. We are denoting it as say P. And this is another particular point, we call it Q. Okay. Now, obviously, you can understand that the coordinate of O is 0 and 0, right? There is no confusion in that.
Yes.
And obviously, there would be the coordinates known of a particular point in the reference frame. Say this is A and B, and this is C and D. All right. Now, say, for instance, there would be an easier solution to this rather than just like joining this PQ. What is this? Okay, let me check it. Okay, first of all, let us forget first of all the coordinates for the time being. Let me show this that particular thing to you. Obviously, you know the distance formula. So from that, like x1 minus x2 whole squared plus y1 minus y2 whole squared, and then square root of it, you can get the distance, right? You know that particular formula, but I'm not going to
Yes.
that. So let us see how can we solve it with vectors. Okay. So now obviously you don't know about PQ vectors, say the distance between these 2 points, or neither do you know about the direction. Sorry, the direction is given, say from P to Q. Now you know the distance of P point from O, and you know the distance of Q point from O, right? Because obviously, if we join OP and OQ, we will get the position vectors. So distance from the origin can clearly be known. Okay, are you getting my point?
Yes.
Okay. So now, if we know the like distance of OP and OQ and the direction of OP and OQ, this can help us recognize what the PQ vector will look like. Okay. So as you will see in the next stages, from the triangular law of vector addition, what you will see is if like say two vectors start from one particular point, say from O point, here we are starting OP vector. Sorry, that's not the triangular formula. Sorry about that. Okay. So the triangular formula is where a particular vector ends, from that particular point, another vector has to start. So where OP vector ends, which vector starts from OP vector's ending point? That is the terminal point P,
PQ.
PQ
Yes.
vector. This will equal to the initial point, that is the O point we started with at the very beginning, and exactly the last point, that is OQ vector. This is according to the triangular law of addition, right? Triangle law of addition or something like that. Law of addition of vectors. Okay. So you will see that. So that is not my point right now to discuss. My point is that, as you can see, if we do not know about like the distance of PQ vectors or something, PQ points, with the use of vector laws of addition and with the use of position vectors, we can easily calculate what should be the PQ vector. Okay. All right. Because if we subtract OQ vector from both the sides, you will get OP vector minus OQ vector equals to uh, minus PQ vector. Okay, sorry about that. So if we multiply by minus 1, then it will turn into OQ vector minus OP vector equals to PQ vector. All right. I hope you understand, right?
Yes, let me just write it down.
Okay, good. Write that down.
Um,
How's your brother doing now? How many days before he takes discharge from the hospital?
another 3 weeks,
That's serious. Okay. So
but
I hope
this
I hope he can come back before the new year, right?
um he can come back before New Year, but he wants to come before Christmas. So,
That would be difficult,
but
right? Because that's only two
yeah,
weeks.
exactly. So it's just trying really hard. Although they did find a blood clot in his heart.
Mhm. So, mm. Okay, your voice is somewhat like metallic. Can you speak again?
Um, I just woke up, so
No, 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 not about that. I mean, like for in the machine, I guess. Okay, all right. Anyway, I am loud and clear, right? You can hear me.
yes,
Okay, good.
yes.
Mhm. So now they have written all these things. You can read them up. So let's see. A vector quantity has both magnitude and direction. So addition or subtraction of vector quantities is not done by usual algebraic rule. As I said yesterday, that you cannot say like 3 vector plus 4 vector equals to 7 vector, right? You have to know in
Yeah.
which direction they are occurring. Okay. 3 vector plus 4 vector is not equal to 7 vector. Okay. It does not work in the algebraic way. So you have to see the geometry between these two and the direction between these two and obviously their angle between these two to get the resultant vector. Okay. All right. So, okay, there is one particular case where addition of vectors would act like the algebraic rule. In which case? Tell me. What do you think?
Yes.
Yes. In which case? That is what I am asking. What
Um,
do you think?
I have no clue.
Think about it. Say, for instance, say this is a boat. Okay. Now someone is pulling it with a 5 Newton force, and another person is pulling it with say 4 Newton force. Okay. Now they are in acting in the same direction. The 5 Newtons direction and 4 Newtons direction is in the same direction. There is no confusion in it, right?
Hmm.
So what will happen is, okay, let me say for instance, there is a resultant vector in this direction, which is the r vector, okay? So what will be the value for r? We know that it will equal to 5 squared plus 4 squared plus 2 times 4 times 5 times cosine. What is the angle between these two vectors? Tell me.
Um, 0.
0 degree, right? Okay, 0 degree.
So we
Okay.
just one.
So then what will we get? We will get 25 plus 16 plus 2 times 4 times 5 is 8 times 5, that is 40. 40. So this will equal to square root of 81. What is square root of 81?
9.
9, right? So as you can see, if two vectors work in the same direction, then their resultant vector's magnitude will be the addition of these two. Okay, you can write this down if you want. Okay, or you can write it simply as if p vector and q vector are two vectors and the angle between them equals to 0 degrees, then resultant vectors magnitude equals to p plus q. Okay, you can write it down in that way. Okay, let me know when you're done writing this, then I will ask you a question.
Okay, good.
Okay, so now if I ask you what will happen if this 4 Newton force works in exactly the opposite direction, what do you think?
It would minus
Right, it would minus. And why would it minus? Because what is the angle between these two vectors? That is 5 Newton and 4 Newton.
180 degrees.
180 degrees, excellent. So we know that cosine 180 degree equals to minus 1. So that means this 40 plus 40 will turn into minus 40 then. And this square root of 81 will become square root of 1, which is in effect 1 Newton. So if I put it like that, if p vector and q vector are two vectors and the angle between them equals to 180 degrees, the resultant vector's magnitude will equal to p minus q. Okay, that will be p minus q.
Yay.
Okay. And okay, let me know when you're done.
I'm done.
Okay. And another special scenario, that is what will happen if these two vectors act in the perpendicular direction? What is your idea about this? So this 4
What do you mean?
Newton is acting exactly perpendicular to this 5 Newton. What will happen in this case?
Um, it would even out.
What do you mean by even out?
Like the average of the newtons will be in use, will be in action
Average.
or
Okay.
force.
Just do this math real quick. What will be the resultant vector? The magnitude, only the magnitude. I'm not asking you to get the direction. Tell me what will be the,
4.5.
sorry? No, no, no.
4.5.
Don't just say it. Do it. Perform the operations. Okay.
4 plus 5 equals 9 divided by 2 is 4.5.
I'm not asking you to do that. Didn't we see a formula for calculating resultant vectors, that is p squared plus q squared plus 2pq cosine alpha, right? Like that. So like plug in the values in this one. Okay. That is what I'm saying. Understand? Now let me,
Okay. Where's my calculator?
Hey, you should be done by now.
Square root of 41.
Square root of 41, right?
41.
Okay. So this equals to, right? This equals square root of 5 squared plus 4 squared. Okay. Which you could say that square root of p squared plus q squared if the two vectors are considered to be like variables as p and q. Okay. So what will happen in case of like the vector is acting in the perpendicular to each other? So it will be square root of p squared plus q squared. Okay, and the angle is 90 degrees. Okay, so these are three particularly very important cases to remember. Okay, because you might get questions like, say, for instance, they will ask you questions. Okay, say 1 mark or half a mark's question. Say the angle between these two is acting like 90 degrees. So what is the probable case of the resultant vector? Is it like p plus q? Is it p minus q? Or is it square root of p squared plus q squared? Okay. So you might get these things. Let me know when you're done.
I am done.
Mhm. Okay, so there are like five laws for addition of vectors. Obviously, we discussed them previously, but let's just revise them. So what is the general law of the two vectors? The end or hit point of the first vector and the initial point or tail point of the second vector are placed at the same point. Then the direction of the straight line connecting the initial or tail point of the first vector and the end or hit point. Okay, okay, okay. Many things written. Just let me explain the image to you. All right. So what is it? Say for instance, this is the initial vector. That is the AB vector. Okay. And what is the initial point of the AB vector? What is the
A,
initial point? A, right? A. Okay, remember that. And what is the terminal point of say AB vector?
B,
B. So now from the terminal point of the first vector, from the terminal point of the first vector, second vector has to start. So which is the second vector then?
C.
BC, not C. C is not a
Oh,
vector.
sorry, BC. Yeah.
BC vector, right? So now BC vector's terminal point is again C. All right. So now what they're saying is first vector's initial point and second vector's terminal point will be joined to get the addition of the vectors. So from this image, what we learn is the first vector is P vector. Okay. And from the first vector's terminal point, Q vector begins. So plus Q vector, which equals to first vector's initial point and second vector's terminal point, which is AC vector or R vector. So they will equal to each other. Do you understand?
Yes.
It might be a little difficult to remember at first, but you will get really easy with this. Okay.
Well, the
Now
magnitude
it's
of P vector and Q vector equal to R vector.
it's not magnitude of p vector and q vector. It's the p vector and q vector itself equals to r vector. Okay. The magnitude will be, see, if you try to put the magnitude, you have to draw an absolute sign in both the sides. Okay. And what will be the magnitude of p vector plus q vector? Okay. So you have to do some algebraic operations or geometric operations to get the absolute value of these two. Okay. You cannot just convert it to p plus q equals to r. Okay. Okay. This is the vectors
Okay.
itself equals to them. Yeah. Okay. Now, I mean, if I just clarify it to you, say for instance, say I am, say pulling a particular thing with 4 Newton in this direction, and another person is pulling it with 5 Newton in this direction, and I am saying that if anybody pulls the rope in this direction with 7 Newton, the results will be equal. Okay, so someone pulling it with 4 Newton in this direction or someone with 5 Newton in this direction, the equal effect of these two will equal to 7 Newton in this direction. But that doesn't mean that 4 plus 5 equals to 7, right? Understand my point?
Yes.
Understand my point? Yes. So that is the thing. Okay. So it does not act like algebraic function. Okay. You have to be very careful about that. All right. Now, this general law doesn't have to that doesn't have to be implemented with three vectors. You could add countless vectors. Okay. You could add countless vectors. So what do I mean by that? I mean by that is, for instance, this, okay, then this, and then this. It starts from here, and the ending point is here. Okay, now it keeps on going in this direction, this direction, this direction, this direction, this direction, this direction, and this direction. So as you can see, say this is the O point. This is say A, B, C, D, E, F, and G. The first vector's initial point ends at A, and from the terminal point, the second vector starts. And second vector ends at point B, and from that particular point, BC vector starts. From the C point, CD vector starts, then so on, so on. You can understand, like wherever a particular vector ends, another vector starts. Okay. Now, after all this thing are done, what we can see is the G point is the terminal point of the last vector in the cycle. Okay, last vector in the cycle. So if we join the G point and O point together, okay, from O to G's direction will be the resultant of all the vectors together. If I put it in like words or like in the equation, it would be something like OG vector plus OA vector plus OB vector plus OC vector plus OD vector plus OE vector plus OF vector. Sorry, not, oh my gosh. One second.
Yeah, please. So it's OA, AB, BC, CD, DE, EF,
Yes, exactly.
FG.
OF plus OA plus AB plus BC plus CD plus DE plus EF plus FG. All right. So this is how the general law of vectors work. Okay. All right. You won't be given like this big of a cycle of vectors, but even if you are given, you know how to solve it. Okay. The answer is very easy. Even if the question setter gives you like a set of 8 or 10 vectors, you can easily understand that what will be the answer. All right. Okay. Let me know when you're done.
Done.
The triangle law, as I've already said, and you could say that triangle law is the a special kind of general law. Okay. Remember, in the first case of general law, what did I say? I said that a vector starts from an initial point and ends at some point. From that particular point, another vector starts. So the addition of these two will be the initial point of the first vector connecting with the terminal point of the second vector. So similarly, from here as well. So AB is say of one side of a triangle. Okay, and this is the direction, like from left to right. Okay, and B is the terminal point of the first side of the triangle. And from here, BC vector starts, and C is the terminal point of the second vector. Now, if you join this A and C together to get a vector, that will be the resultant of AB vector plus BC vector. They have written various things here and there, but that is not important. Okay, you just have to remember this particular thing. Okay, tell me, do you understand?
Yes.
Okay, and another important thing I have to mention here is say, this is BC vector, right? This is say BC vector. Okay, let me draw it. Say for instance, this is our PQ vector. Okay, PQ vector. Now, if I tell you to draw down QP vector, what will you do? Obviously, you can understand that the points are similar. Okay. But in case of PQ vector, the initial point is P and the terminal point is Q. However, in case of QP vector, the initial point is Q and the terminal point is P. So what happens? See here. Doesn't the direction alter to 180 degrees or just become the opposite from the first vector? Tell me.
Yes.
So doesn't that mean that PQ vector could equal to minus QP vector? Understand my
Whoa.
point? See, PQ vector said the value for this is 5 newtons. Okay. And QP vector is also 5 newtons, but in just the opposite direction. So if I just want to like rotate it 180 degrees, I just have to multiply with another minus 1. Because minus obviously just what does it do? It does is just like what can I say? Opposites the particular thing. Okay. Whenever you will have you read complex numbers.
Not yet.
Okay, when you will read about complex numbers, you will get a clear idea about why multiplying it with minus 1 equals to 180 degrees. Okay, there is a particular, like, very important thing in mathematics. There is I. Okay, I means imaginary number. Okay, from that portion comes I. Anyway, so for the timing, just remember that multiplying something with minus 1 means that it rotates just 180 degrees. Okay. Say for instance, you are going in the north direction, say for 5 meters. Okay. If you go exactly to the opposite direction, that is going to the south for 5 meters, you could say that you are going minus 5 meter to the north. Okay. If you consider the upwards direction to be positive, then downwards direction is obviously negative. Same goes for the system of axis. See, in the right side of the x-axis, you get positive. In the left side of the x-axis, which is exactly 180-degree opposite, you get negative. In the upwards direction of the y-axis, you get positive. And exactly 180 degrees to the other side, you get negative. So there are various instances where you understand that why, like, minus sign is like exactly 180 degrees to the other side. Okay. Am I clear? Why PQ
Yes.
vector equals to minus Q vector. Okay. Correct. Okay. So if the question setter asks that what is the value of, say, AB vector plus BA vector, what will be your answer? Tell me.
0.
0. 0 is the magnitude. And what is the term of the vector? What is the name of that vector? It's
Resultant.
the No, it's a null vector, right? A
Resultant.
specific.
Null
Obviously, it's a
vector. Oh, yes.
resultant, but it's a null vector, right? Specifically, it will be
Yes.
called null vector. All right. Okay. Law of polygon. Okay, it's quite the same. See, say this is the point O again. So from the point O, you have got, say, OA vector. All right. And then from this terminal point, say, don't even consider OA vector, just consider from this point to this point, this A vector as they have written. Now, from this terminal point to this point, this is a B vector, right? So if you add
Yes.
join these 2 points from the triangle law, you can understand the resultant is A vector plus B vector, right? Is it correct?
Yes.
Now they have kept on doing this. Then again they have joined with A vector plus B vector. They have joined C vector. So that means this particular side of the triangle will be A vector plus B vector plus C vector, right? Is it correct?
Yes.
Then again you have joined D vector, so that will be A vector plus B vector plus C vector plus D vector. Okay. Then again you
Yes.
have joined another one. So in this way, you could work with the polygon law of the vector. Like, I mean, If you would like observe closely, you would understand that all the things are like quite the similar with each other, right? There is no particular, say, vast amount of difference. But based on our need, we change. Like, which one do we know need? Okay. But I would suggest the component law, which you would see, I guess, in the next few pages. It's the most important thing that you will need. Okay. Anyway, so let's just read out this thing. So this law states that if a vector polygon be drawn, placing the tail end of each side, tail end means the what can I say? It's the initial point. Okay. Tail end means the initial point of each succeeding vector at the head or arrow end of the preceding one. Okay, their resultant is drawn from the tail end of the first so this is the tail end. I mean, you just say initial point and terminal point, okay? Because you might get confused with the tail end, okay? Of the first to the head or arrow end of the last, okay? So, see, R vector equals to A, B, C, D, and E. Okay, all of this added together, okay? Again, I am saying this is the addition of vectors, not their magnitudes, okay? Not their value, okay? Okay, let me give you another link, okay? Just a second.
Okay.